In the last video, we learned how to find the common multiples of a set of numbers and the least common multiple by listing out the multiples of the individual numbers, picking out the common multiples, and the lowest, the smallest was the lowest common multiple. In today's video, we're going to learn how to find the LCM of a set of numbers using the division method. When we use the division method, we simply follow these steps. Number one, write the given numbers in a horizontal line, separating them using commas. So we are going to write this set of numbers we want to find the LCM and separate them using commas. Next, we will divide them using the smallest prime number, which can divide at least one of the given numbers without a remainder. Next, we will put the quotient directly under the numbers in the next row. If the number is not divided exactly, we bring it down in the next row. Alright, so this means that when we want to start the division process, we will start with the smallest prime number, which can divide at least one of the numbers. We all know that the smallest prime number is 2, so you're going to use 2 if 2 can divide any of those numbers without a remainder. If any of the numbers is not divisible by 2, we simply bring it down. Then for the others that are divisible, we will simply write their quotients in the next row. Next, we are going to check if 2 can divide any of the new set of numbers. If yes, we continue using it. That's why we have here, when the prime factor used can no longer divide any of the numbers, assuming 2 can no longer divide any of the numbers exactly, we move to the next, which will be 3. We will check if 3 can divide any of them, we use it. If not, we move to the next prime factor, which is 5, and so on and so forth. So we will continue the division process until we have 1 as a quotient for all the numbers. Right? We will keep dividing until we have 1 as a quotient for all the numbers. Example 1. What is the LCM of 2, 4, and 8? We will arrange these numbers and separate them using commas, right? And then we will look at the first prime factor to use. Now, we have 2, 4, and 8. 2 can go into 2 and 4 and 8, so we will use 2. So 2 into itself is 1, into 4 is 2, into 8 is 4. Since 2 can go, we use 2 again. We already have 1, we bring it down. 2 into itself is 1, into 4 is 2. Since we have 1, 1, 2, 2 can go, so we use 2 again. We bring down 1, 1, 2 into itself is 1. So the LCM of 2, 4, and 8 is 2 times 2 times 2, which is equal to 8. Example 2. What is the LCM of 5, 8, and 10? 5, 8, and 10. 2 can go into 8 and 10, so we will begin with 2. 2 cannot go into 5 without a remainder, so we bring it down. 2 into 8 is 4. 2 into 10 is 5. So we have 5, 4, 5. Since we have 4 there, we can use 2 again. 2 into 5 is 2 times remainder 1. Since there's a remainder, we will simply bring down our 5. 2 into 4 is 2. We bring down 5. Since we have 2 here, we can use 2 again. 2 cannot go into 5 without a remainder, we bring it down. Into itself 1, we bring down 5. Now at this point, 2 cannot go again, so we use 5. 5 into itself 1, we bring down 1, into itself 1. So the LCM of 5, 8, and 10 is 2 times 2 times 2 times 5, which is 40. Using the same method, please find the LCM of the following. Solve on paper, snap and send. Thank you.